Alright folks, today we're working on 10.2b, which is geometric series, and we're only going to deal with finite geometric series. That says that they have an end. You don't have to worry about infinite geometric series unless you get to pre-cal or calculus. So right now we're just going to talk about the ones that end. So like a sequence, like given the sequence 5, 15, 45, 135, part A asks us to evaluate the related series algebraically, or sorry, explicitly, and part B is evaluate the related series algebraically. So when I say explicitly, remember that a sequence and a series differ by what happens to them. So the sequence is the pattern of numbers 5, 15, 45, and 135, but the series is just where you add that pattern of numbers up. So let's see, 5 plus 15 plus 45 plus 135 gets us 200. We don't have to know anything about the series at all. We don't have to know if it's geometric or algebraic. It doesn't matter. All that matters is that you can just add them up. That's what it means. So if you have a pattern you can't figure it out, you just have to evaluate the series. Just add them up and see what you get. It might take a little while, but it'll always work. So we should get 200 however we evaluate this. So let's talk about algebraically. So if we're looking at our series, our sequence 5, 15, 45, 135, and I said sorry because if we have a comma in the middle, that says it's a sequence. If we add them up, that says it's a series. We have to figure out our pattern because it asks us to do this algebraically. So yes, this is geometric sequence, but let's make sure we know how. Let's see, to go from 15 to 5, we get 3. Let's see, 45 over 15 gives us 3. So yeah, so we just multiply by 3 every single time. Let's just check 45 times 3. Yeah, it gives us 135. Okay, that works. So that says our common ratio for this one is 3. We know our first term in this sequence is 5. And hopefully, that's all we need. So let's use the algebraic formula for this. So if you look on your blue formula sheet, I'm looking under geometric series, because that's what we're working with right now. And so geometric series is right here, and the formula is given to us right here. And remember, if you need another one of these, I have extras. Don't think that you just have to do this by yourself. So this is evaluated with this formula. S sub n equals a sub 1 minus a sub 1 r to the n power all over 1 minus r. And we know what a lot of these things are. We know a sub 1 is our first term, r is our common ratio, n is the number of terms we have, and that r is the same thing again. So let's count how many terms we have because we don't have that yet. So n equals, we've got 1, 2, 3, 4 of them. So n equals 4. So we're finding s sub 4 equals a sub 1, which is 5, minus 5 times our common ratio of 3 to the n power, we know n is 4, all over 1 minus r, and r is 3. So I'm just going to type the top in my calculator carefully. So 5 minus 5 times 3 to the 4th. And I'm going to get negative 400. So let's see, 3 to the 4th times 5. So we're saying 5 minus 405. Yeah, it does give me negative 400. Okay, that worked out. And then 1 minus 3 is going to be negative 2, of course. I don't know why it's only negative 3. That's weird. Negative 2. So we get negative 400 divided by negative 2, which gives us 200. Two negatives cancel to make a positive. 400 divided by 2 is 200 because 4 divided by 2 is 2. 2 zeros afterwards. So yes, we got the same thing, whether we did it algebraically or explicitly. So let's talk about some of that sigma notation that we have. So we have a geometric series given in this sigma notation. Remember, the sigma notation says we're just adding these up, and it uses this formula for that the entire time. So we're going from 1 to 4. I'm probably just going to evaluate each of these at the 1 to 4 interval. So I'm going to copy this down. So from n equals 1 to 4 of 3 times negative 2 to the, let's see, the n minus 1 equals, I just scribbled that out for a reason, I just thought of a thing, don't worry about it, we're cool. Okay, so we're evaluating n equals 1 first. So 3 times negative 2 to the 1 minus 1 plus, let's see, 3 times negative 2 to the 2 minus 1 plus 3 times negative 2 to the 3 minus 1 plus 3 times negative 2 to the 4 minus 1, and we stop here because our last number is going to be a 4. Okay, so this is a lot of work just for adding 4 up. Okay, so let's just figure out what we get for each of these. I'm going to do the subtraction in my head, so I don't have to type it into the calculator. But if you type this into the calculator, you'd better darn well make sure that those exponents are in parentheses. So negative 3 times negative 2 to the, let's see, 1 minus 1 is 0. So we should get 3 as our answer. So let's just type in, I'm sorry, not negative 3. 3 times negative 2 to the 0 still should give us, oh, no, it doesn't. It gives us a sign change. So it should, and the problem is here's this. When your calculator sees negative 2 to the 0 power, it should give us 1. We want negative 2 to the 0 power. So make sure that you compare and contrast these. If you're raising a negative to a power, put it in a parentheses, please, because we want 3 times negative 2 to the 0 power, and 3 times 1 is 1. Okay, so 3 times negative 2 to the 0 power is going to give us positive 3. That's the actual value we want. So be careful when you're typing this in your calculator. It will lie to you on a regular basis. Okay, so 3 times negative 2 in parentheses to the 2 minus 1 is 1. This will be negative 6 plus the next one. Let's see, 3 times negative 2 in parentheses to the, let's see, 3 minus 1 is 2. So that's, let's make sure this is right. So 3 minus 1 is 2. 3 times negative 2, yep, gives us 12. Okay, plus, and the last one, 3 times negative 2 to the, let's see, 4 minus 1 is 3. So that gives us negative 24. So I evaluated each of my individual components, and then now I can just add them together. So 3 minus 6 plus 12 minus 24. It's going to give us negative 15. Done. Okay, so that one's pretty straightforward. We just have to evaluate each of the individual ones. But when I look at example 3 down here, evaluate the geometric series from n equals 0, and this is new, to the 19th one of 2 times 3 to the n power. So, I don't want to do this 19 times. I mean, yes, I could do this 19 times, but I don't want to. I think that's going to be some terrible, do a whole lot of things for no purpose indeed. So let's try to use our geometric series algebraic formula and figure out what we need to from there. Okay, so let's remember, when we start counting, we usually start counting at 1, right? So, if we count from 0 to 19, that's going to give us 20 terms. 1 all the way to 19 is 20 of them. So really, we have 20 terms in this problem. And remember, if we're going to use this, we need a sub 1, r, and an n. So there's an n, we need a sub 1, and we need r. Remembering back from our geometric sequence formula, we know that that number that's being multiplied in the front, that's always our first term. So our first term in this problem is going to be 2. And more than that, we could just evaluate the first part of the sequence if we want to. 2 times 3 to the 0 power is 2 times 1, which is 2. Okay, because 2 times 3 to the n is 0, which is 2 times 1, which is 2. So yeah, we can just use that. Our r is whatever we're multiplying by on a consistent basis, and that's what our exponents are used for. It says we're doing a whole lot of repeated multiplication. So that r is 3 because it has the exponent attached to. We're multiplying by 3 a ton of times. So now that we have an a sub 1, an r, and an n, we're just going to use our formula. So s sub, let's see, n, I'm just going to copy down the formula from our worksheet. S sub n equals a sub 1 minus a sub 1 r to the nth power all over 1 minus r. So I'm going to have a sub 1 is 2 minus 2 times r is 3 to the 20th power, because 0 to 19 is 20 of them. 1 minus r is 3. Okay, so I'm going to type the top of my calculator. 2 minus 2 times 3 to the 20th. Oh, that's a big number. Okay, let's just copy it down and put the appropriate commas in the right spot. 5, 6, 8, 8, 0, 0. Okay, so 3, 3, and 3. Let's see, thousands, millions, billions. Negative 6,973,568,800. Okay, big old number. And then 1 minus 3 is negative 2. Okay, last step, divide that by negative 2. And we're going to get as our s sub, I guess s sub 20, because I've got 20 of them. I'm just going to copy this number down. 3, 4, 8, 6, 7, 8, 4, 4, 0, 0. So thousands, millions, billions. So 3,486,784,400. which says if I was to try to add up all these 19 just in a row, I probably wouldn't do so well on that. So let's make sure that we have this written down. I'm going to slowly slide this page all the way up to make sure that you have each and every answer we're looking for, and then I will let you get some practice on your worksheet for this. Slowly sliding it up, and if you need to pause and go back, don't forget this is video, do that.